We're using squares of side length 1 or 2 and an equal number of each to try and put them together to make another square. And we want to find the smallest square where it would work. So I've got my 1 by 1 square and I want the same number of 2 by 2 squares. So the area of this is 1, the area of this is 4. So the area together, area of a pair, will equal 5 centimeters squared. So if we use n of them, n pairs, then the area will equal 5n. And 5n must be a square number because it's the area of a square after all. So n must equal a multiple of 5, but in fact a multiple of 5 that's also a square number. So 5 times, let's call it x squared to ensure this. So because we want the smallest square, let's go with x equal to 1 to start with. Then n will equal 5, we'll have 5 pairs, and the area will be 25. So if I imagine drawing out this grid, I'm going to first of all place my 2 by 2 squares in the grid. So I could, if I'm trying to fit them in, I could maybe put one in the corner and then one next to it, one above the red one, and then one here. But I cannot fit my fifth square, 2 by 2 square in. And there's no way that I could possibly do it because you get this little row going down there. So whilst this satisfied the conditions of getting the correct area, we couldn't actually manage to fit them in. So let's go ahead and look at the next biggest value of x, which would be 2. Then n would equal 5 times 2 squared, so 20. And the area would be 100. So we now need 20 of each. Let's give this a go. Okay, there's 10 like that. To be honest, when I did it, I said we could use 22 by 2, and that would give us 80, and 21 by 1 to give us 20, so overall 100. And I said it would fit together, but really, to be comprehensive, we should just show it we can. So we've got 1, just like I did before, 2, 3, 4, 5. And that's great because we can fit, and that might even be enough, can fit 5 2 by 2s in a 2 by 10 slot. So can fit 20 in an 8 by 10 slot. So I'm just going to outline it now. Like obviously we can just get these all the way up. And you can even miss out on one. It doesn't really matter. Because I've got my 20 2 by 2s. And then finally we're just going to have our 20 1 by 1 squares in between. So there's lots of different ways that we can arrange them in this once we've got to here. But that is enough, I think, to show that it works. So let's just recap. We have to have the same amount of each. So it's got to be a multiple of 5 because that's the area of a pair. We wrote that then as the area as 5n, where n is the number of pairs. Recognize, therefore, that n has to be a square number. In fact, a multiple of 5 that's a square number to ensure that we get an area of a square, which is a square number, which we always will. We tried the smallest value of x that we could. It just didn't work. We tried the next value of x up to give 100 by 100, sorry, 100, a 10 by 10 square. Saw that we can fit this in. I sort of wrote it down and I felt like I justified it enough here, but just to make it even more comprehensive, I sketched it out. And that is enough to say that that is the smallest square. Brilliant. So I should probably just say 10 by 10. 10 centimeters by 10 centimeters.